Hello, Mr. Sutton here with the Pre-Cal Honors 4-7 Part 1 homework solutions on applications of exponential equations. For this problem, during the exponential phase, we have some bacteria increasing at a rate of 1.2% per minute with a current population of 142 million. In how many minutes will the population reach 152.8 million? So for this one, we'll start with f of t equals ab to the t. We just need the standard exponential formula because this is happening per minute, not every 7 minutes or something crazy like that. Plugging in everything now, we have a target amount of 152.8. That's what f of t is going to be. A value, our starting amount, is 142 million. Our b value, our growth factor, is going to be 1.012 to represent the 1.2% that we're increasing. And t we're still looking for, so that will remain a variable. All right, so to solve for t, we have to isolate the exponential term, divide both sides by 142. And now to get t out of the exponent, we're going to log both sides. So we have log of this fraction equals t log of 1.012. Dividing both sides now by log of 1.012 to get t by itself, we're going to end up with whatever the calculator gives us. So here's what I'm entering in my calculator. I used alpha y equals to get these fancy fraction sort of formattings that I have going on here to make it a lot easier to look at. If you don't have that, then just be careful with your parentheses. That should come out to 6.15, and that's going to be minutes for this problem. For this problem, we have a savings account balance compounded continuously. If our interest rate's 4.4% per year and the current balance is this, in how many years will the balance reach this other number? Since we're compounding continuously, we need to use the PERT formula, f of t equals pe to the rt. So plugging everything in now, we have a target amount, an f of t amount, of $1,431.80. Our principal, our p, is the $1,144, and then we'll have e to the 0.044 for the r value, and t is going to be a variable because we're solving for t. We want to know how long. Next, let's divide both sides by 1,144 to get the exponential term by itself. And now I have to log both sides to get t out of the exponent. Now when I do this, I'm going to use ln because the ln of e is 1. So I'll have ln of this fraction equals 0.044t times ln of e. But since ln of e is 1, I'm not going to bother writing it. I can just leave it out. So that saves me a little bit of time using ln instead of normal log. All right, to get t by itself, I'll divide both sides by 0.044. And now whatever the calculator gives me is my answer. So to plug everything in my calculator, I used alpha y equals to give me this fancy fraction on several levels here. And then I press enter, giving me 5.10. And that's going to be in years. For this problem, we have this made-up element jacksonium with a half-life of 18 months. If there's 27 now, how long will it take the isotope to decay to 10 pounds? Since we're talking half-life, let's use the half-life formula of f of t equals ab to the t over k. F of t itself, that's our target amount of 10 pounds. That's what we're figuring out how long it'll take to decay to. The a value is our starting amount of 27 pounds. For b, we've got 0.5 or 1/2 because this is half-life. T is still going to be a variable. K is the half-life amount of 18. And now we're going to solve for t. We'll start by dividing both sides by 27 to isolate this exponential term over here. And next we'll have to take the log of both sides. So we have log of 10/27 equals t over 18 times the log of 0.5. Next, we're going to divide both sides by log of 0.5 and multiply by 18. So I'll have 18 times log of 10/27 divided by log of 0.5. And now I need to plug this in the calculator. So I did alpha y equals to get this fraction bar. I've got 18 log of fraction bar, 10 over 27, all divided by log of 0.5. And that should come out to 25.79, and that's going to be months. So there we have it. For this problem, we have an island's population growing at a rate of 4.4% per year with a current population of 1615. We want to know how many years it'll take the population to reach 2,188. So since our population is growing at this rate per year, we can use our simple exponential formula of f of t equals ab to the t. We have an f of t amount of 2,188. That's our target output. We start with an a value of 1,615. That's our starting number of people. And our b value, since we're growing at 4.4% per year, that's going to be 1.044. And then t is going to remain a variable. To start this off now, we'll divide by 1615 to isolate that exponential term. Now we have to take the log of both sides. So that's log of the fraction equaling t log of 1.044. Next, we divide by the log of 1.044 to get t by itself. And now it's time for the calculator. So if you're wondering how I got this fancy fraction, I did alpha y equals and then n over d gives me the fraction bar. So pressing enter on all that now, we've got 7.05, and that's going to be years.